Hey there and welcome. Today, we're going to talk about the hidden superstars of modern engineering, composite materials. You might not realize it, but they're everywhere. In the planes we fly, the cars we want to drive, and even in the tech that gives us clean energy. So, what exactly are they?
Think about this for a second. What if you needed something stronger than steel, but as light as plastic? It sounds impossible, right? Like a riddle. Well, that exact engineering challenge, that need for something that is both incredibly strong and incredibly light, is precisely why composite materials exist. So, here's what we've got lined up. First, we'll break down what composites actually are. Then we'll get into their superpower advantages. After that, we'll look at where they pop up in our world, see how they perform when we push them to the absolute limit, and finally, we'll look to the future and ask, what are we going to build next?
All right, first things first. What are we really talking about when we say composite material? Well, it all boils down to the power of teamwork.
See, a composite isn't just a simple mix. It's a really clever combination of at least two different things. You have a strong part, the reinforcement, which is usually some kind of fiber, and then you have the matrix, which is the stuff that holds it all together. You combine them, and boom, you get something way better than either one could ever be on its own.
You've probably heard this old saying, and it absolutely nails the core idea of composites. You're not just adding stuff together. You're creating this amazing synergy, where the final material has fantastic properties that neither of the ingredients had to begin with.
Okay, let's look at a classic example. Imagine you take carbon fibers, which are super strong but flexible, and you embed them in an epoxy resin, which is hard but kind of brittle. On their own, they've got some pretty big flaws. But when you bond them together, you get carbon fiber composite, a material that is just ridiculously strong and unbelievably lightweight.
And you know what's wild? This is not a new idea. Humans have been making composites for thousands of years. Think about reinforced concrete. You've got steel bars, or rebar, that give the brittle concrete the strength it needs to resist being pulled apart. Even ancient mud bricks with straw mixed in. It's the exact same principle at work.
So now that we know what they are, the big question is, why? Why do engineers go to all the trouble of making these materials? Well, it's because they have some serious superpowers.
It really comes down to four key advantages. First, that mind-blowing strength-to-weight ratio we keep talking about. They're also super durable, and unlike metals, they just don't rust or corrode. You also get this amazing design flexibility, which lets you create all sorts of complex shapes. And finally, they have fantastic fatigue resistance, which means they can handle being stressed over and over again without falling apart.
And this chart, this really puts it all into perspective. Look at this. For its weight, steel is pretty strong. Sure, aluminum's even better. But carbon fiber composite, it's in a completely different universe. It's not even a close competition. This right here is the game changer for literally everything from aerospace to pro sports.
So where can you actually find these amazing materials? Well, they are all around us, in things you use every day and in the essential technology that powers our entire world.
Let's start with something you might have in your own garage, a high-end racing bike. You know that frame that feels like it weighs nothing but is stiff as a board? Yeah, that's almost definitely a composite material.
And what that means for the rider is huge. The lightness gives you incredible acceleration, and the stiffness means that every single bit of energy you put into the pedals goes directly to moving the bike forward, not to flexing the frame.
Okay, now let's scale up, way up. Think about those massive, graceful blades of a modern wind turbine spinning high above us. These things can be longer than a football field. They have to be strong enough to survive hurricane-force winds, but somehow light enough to start turning in just a gentle breeze. Honestly, composites are the only materials that can do that job.
All right, so we've gone from the everyday to the essential. Now let's go to the extreme. What happens when these materials get put into situations where failure is just not an option? Well, you can't get much more extreme than a Formula One car. It's one of the most demanding engineering environments on the planet. This insane balancing act between raw speed, low weight, and most importantly, safety. The very core of the car, right where the driver sits, is something called the survival cell. It's basically a cocoon made from an incredibly tough carbon fiber composite, and it's designed to be practically indestructible, protecting the driver from the unbelievable forces of a crash at over 200 miles per hour.
And that brings us full circle, right back to that challenge from the very beginning. Aerospace. The perfect poster child for this is the Boeing 787 Dreamliner.
An airplane that completely changed the game for air travel.
50%. Just let that sink in for a moment. Half of the entire airplane, by weight, is made from composite materials. And this massive weight savings doesn't just save a ton of fuel. Because composites don't get tired or corrode like aluminum, the airline can keep the cabin air at a higher humidity and a lower altitude pressure. For you, the passenger, that means less dehydration and less jet lag. It's just a way more comfortable flight.
And finally, we go to the ultimate extreme environment, space. When you are building something designed to literally leave the planet, every single gram matters. Spacecraft depend on composites not just to shave off precious weight for launch, but to survive the absolutely brutal conditions out there, from the crazy temperature swings and damaging radiation to the literal fire of re-entering Earth's atmosphere.
So, from ancient mud bricks to modern spaceships, composites have obviously been with us for a long time. But when you look forward, it really feels like we're just getting started. So what's next? You know, these materials are right at the heart of our push for a lighter, faster, more efficient world. Whether we're talking about making electric cars lighter to get more range out of their batteries, developing more advanced prosthetic limbs, or even designing buildings that can survive natural disasters, the next wave of innovation is absolutely going to be built from composites.